Hello, welcome to Math Topics with Jeff. Today we are going to be going over 3 ways to find limits. This is Calculus 1, 2 topics, so bear with me. Anyways, we see that we have a rational expression. And when we plug in the x, that value that's approaching, we plug in 3 for x, we see that our denominator is 0. Now, the thing about that is that we can't have that. Your denominator can never be 0. And so basically, we're going to be doing 3 ways in order to cancel that out. So, first way, this is what we call factoring. We rewrite our limit right here. Limit as x approaches 3. And because we are going to be rewriting these variables out, we have to keep this limit notation right here. Remember to keep the limit notation until you're not using variables and you're just plugging numbers in. And so with difference of squares, we can factor this to x minus 3, x plus 3, and then we just keep our denominator. And then now we just simplify. That cancels out. So now when we rewrite it, so far we got x plus 3. Now that is a solvable equation. So that is a solvable limit. So now when we plug in 3, it's just going to be 6. Simple, easy. This is factoring. All right, now this is so this way we're going to be solving this problem. Obviously, if we plug in 9 again, the denominator is going to be 0. In order to solve this, we're going to have to do rationalizing or conjugation. And so what we're going to do is essentially, because also we have this square root right here, that whenever you see a square root, that is a major indicator that you're going to be doing conjugation / rationalizing. And yeah, let's just get into it. So we rewrite our limit right here as x approaches 9, and then we're just going to rewrite this whole what they gave us, x minus 9, and when we rationalize, going to x plus 3 times square root of x plus 3. What you do on the top, you must do on the bottom. Always remember that. And so now, when we rewrite it, limit as x approaches 9, we will actually have x, because the square root times the square root equals the value that's inside. We'll just have x, and then we'll have minus 9 over x minus 9 original denominator, parentheses, square root of x plus 3. And so right here, we see that we can cancel these out. And a mistake that people tend to make is when they cancel those out, they might get a little bit lost or stuck. They don't know what to, because we see that obviously this is in our denominator, but they might be stuck on the top. Guys, this is just 1. We just have 1 on the top, and same thing right here. We had 1 whenever we canceled these out. It's just that because it's on our numerator side, when we distribute, even if we distribute that 1, it's literally still going to be x plus 3. So just remember that, multiply that. And so now that we have 1 up here, and we have a denominator to where it looks like, it looks pretty fast, solvable to me. So we can find the limit. So we plug in 9 for x. So now that we're just plugging in, so we don't have to write this anymore. So when we plug in 9 plus 3, we know that the square root of 9 is 3, so it'd be 1 over 3 plus 3, which is just 1 over 6. Very easy, very simple. Now this one is a little bit funky. I'm not even gonna lie with you. This one, we're gonna have to find the uncommon multiple. And so essentially, with this limit, we're gonna rewrite obviously our x approaches 2, and then we are gonna find the common multiple, and it's gonna be 2x multiply this, and then bam, bam. Sure, teacher taught you about that. But since they just share the same denominator, we don't need to write two separate. You can if it helps you visualize, but they're literally the same denominator, so there's no need to. So then it'd be 2 minus x. But if it really helps you to, you can write 2 over 2x minus x over 2x. But in my opinion, in this problem, it just complicates things, so there's no point. And we still have the same numerator or denominator. So now this is what we're going to be doing different. We're going to rewrite this limit as x approaches 2, and this big line right here, this indicates that we are going to be doing division. And if you remember back in our early days when we're dividing fractions, we know that what's essentially on top right here. So it'd be, we keep it to 2 minus x over 2x divided by x minus 2. Well, because x minus 2 is like, it doesn't have any, it's in the numerator. Essentially, this is how it looks like. We don't see that one, but it is there. And so now what we're gonna do is we're actually gonna find the reciprocal, and this 1 will be on top, x minus 2. And so that's exactly how we're going to do it. Multiply by the reciprocal, 1 over x minus 2. And people might get a little bit like, oh, you can't cancel these out. Yes, I promise you can, because this is the same thing. This right here, 2 minus x, is the same thing if we just literally take out a negative and switch their places, x minus 2. It's the same thing. You see, we'll still get a positive 2. We plug in that distribute that negative, we'll still get a positive 2. Negative x as 2 minus x, yeah. It's the same thing. So now we can finally actually cancel those out. And then, so on top we'll just have, it'll be, when we rewrite it, will be limit of as x approaches 2. And on top we'll have, don't forget about your negative, that negative that's there. We'll have negative 1 over 2x. And now, this is a limit that we can plug in, that we can solve, and there's no 0 in the denominator. So when we plug in 2 over 2, get negative 1 over 4. There we go. And this is 3 ways to find limits: factoring, rationalizing, and then multiple. There we go. I hope this video helps in understanding new ways, a different way to find limits. Thank you for watching the video, and stay blessed.